Welcome to On the Metal, Tales from the Hardware-Software Interface. I'm Bryan Cantrill. With me, as always, is Jess Frazelle. Hey, Jess.
Hey, Bryan.
All right, so we got a very exciting guest here in the garage today. Do you want to introduce our guest, Jess?
Yeah, so we have Tom Lyon, and I think that what we should start with probably is what he brought us.
Yeah, Tom, you brought us a gift. First of all, welcome to the garage.
Thank you. Great to be here.
And not that this should be the expectation for everyone coming into the garage. But that said, we do honor the fact that you have brought us a terrific gift. So do you want to describe what you brought us?
Well, I'm a collector of computing artifacts, mostly manuals, but every now and then something else, but not huge amounts of hardware like some people. But I got a bag full of buttons and indicators from IBM 360. So what I have for each of you is a ready light from the IBM mainframe.
It's
so cool.
It's so cool.
And it's also our color green.
It is the green that we have for Oxide, which is great. It also has got such heft to it. And you had an interesting little anecdote about the origin of Ready.
Yeah, so apparently in the 50s sometime, somebody was going to have an idle light on the mainframe. But an executive at IBM came along and said, oh no, our machines are never idle. Let's call it Ready. That's
genius. I mean, you really have to admire that. That is really, there is something. And why do we not call it that? We should call it the ready loop, not the idle loop. I mean, it really is. It's unfortunate that idle kind of reinserted itself into our lexicon. Right. Because ready is really a much better term. My teenager is not idle. He is merely ready. Right. Actually, in my case, he's idle.
I'm ready for work often.
Yes.
Exactly.
No, it's good.
It's good, but thank you so much for this. And so when did you, I mean, it's interesting that you've been collecting this kind of, and you've got a terrific artifact in your offices at DriveScale, an actual platter from a spindle. You want to describe that one a little bit? That's an amazing artifact.
Yeah, actually, I have two giant platters, one a 26-inch and one a 31-inch. They're both from 1961, I think.
Whoa.
Wow.
And hefty discs that were, magnetic disc. And the units that they went into were these gigantic things because they had a lot of these discs lined up together. I've actually been trying to collect one of every size of platter ever made.
Wow, that's cool.
That is awesome.
The tiniest is a 0.85 inch.
Okay.
Whoa.
That Toshiba made with a USB interface. And that was killed off. That was very recent as well, but killed off by flash memory.
Right. So your criteria is this needs to be rotating media. This has to be a spinning platter.
Yeah, just for fun.
0.85 inches on a platter. That's amazing.
Really small.
Yeah.
Because you could collect flash, but it's just chips.
Oh yeah, no,
boring.
No. This is a much better hobby.
Right. And then the largest ever made, and I think there were only 2 or 3 ever made, a 48-inch platter.
Holy God!
And Stanford had one, and Lawrence Livermore had one. And the trouble was they were so huge that when they changed temperature, everything would get out of alignment.
Totally,
because there were too many types of metal.
Well, you've got. I imagine you've got a lot of problems, and then also just the angular momentum you have.
Right.
I mean,
scary.
Like you could actually hurt somebody. I imagine.
Yeah.
What was the speed of those platters? Do you know? Was it it must have been.
They were like 1,500 RPM.
Right. Okay. Yeah. And I can't remember. I came across it. Maybe it's apocryphal that if you get below about 1,200 RPM, you begin to lose. It becomes the aerodynamics become really complicated.
Yeah, I don't know. But what's interesting is that at some point they figured out making things smaller made everything more rigid, and life was much simpler as they made things smaller.
Oh, wow.
Right. Wow. So and we talk about on the metal. I mean, that platter you've got, it is metal. I mean, because Jess, you've not seen it, right?
No, I saw the picture.
Saw the picture. Yeah, it is. I mean, how much does it weigh, Tom? I mean, it's got to weigh
15 pounds, maybe.
Oh, wow. Okay.
Yeah. I mean,
that's hefty.
It is absolutely hefty. And that came out, was it a Librascope or what was the machine that came out?
Librascope were the guys who had the 48-inch.
They were oh, wow.
This came out of a Burroughs and a Data Products.
Oh, cool.
That did stuff for lots of vendors.
Wow. And this is a machine that predates you, I assume. I mean, this is not a machine that you ever saw or worked on.
I had no personal connection with that.
Right. But just a curiosity. Well, I love that. when I was a young technologist, I developed that same interest in the history that had come before me. And you obviously had the same thing boy, what did come before me here?
Well, the other really cool thing I got not too long ago was a memory scope from an IBM 704.
Okay.
And that was IBM's first commercial computer.
Right.
And the memory was on CRTs, right? So you had a 32 by 32 bit pattern on a CRT was 1K of memory. So I got one of those CRTs, and the computer had, I forget whether it was 36-bit or 40-bit wide words. And they had one bank of CRTs with the detectors on the front, so you could read back the bits and refresh.
So how did the memory work? Is it using photoreceptors?
It's using the phosphorescence to store the bit, and then you would read it back and refresh it every so often to keep it going.
Oh my gosh.
Which is not that different than DRAM.
No, I mean, it isn't. Right. It's like, why should that seem so insane when we do basically the same thing with capacitance that they're doing with phosphorescence?
Right. But the cool thing was they had one bank of things, which was the memory, and another bank of CRTs with the same display on it that you could look at and see what was going on.
Wow, that is really interesting. And how effective was that memory? Was it
great.
Lossy? It was good.
It was good, and it was very fast.
Right. Density, I imagine.
Yeah, density sucked.
Density sucked, right.
But until core memory came along, that was the hot thing.
So this is pre-core memory.
That's crazy.
And this is like maybe post-Mercury delay lines. Right. Which has got to be some of the earliest in terms of memory.
Yeah, UNIVAC 1 was Mercury. And that was just a couple of years before this.
I assume if you come across a Mercury delay line, you're not going to purchase that. That feels a little, exactly. That feels a little too dangerous.
And probably they're not going to be allowed to put it on eBay.
Yeah, that one seems like so do you know how a Mercury delay line works? No. Justin, do you want to explain a Mercury delay line, Tom?
Well, basically it's a long, narrow vat of mercury. And by disturbing it at one end, you create a wave, which represents a bit. And you sense it at the other end. So now you've stored the bit for the amount of time it takes to go from one end to the other.
Whoa. Okay. So like thermometers are mercury.
Right.
Like
thermometers
traditionally.
are mercury. Yeah. So I mean, I assume it's the mercury. It was the viscosity, I would assume, of the mercury. I mean, it's obviously properties of mercury that make it particularly amenable. I mean, presumably you could make a delay line out of other liquids. It would just be much more lossy or complicated.
Yeah, I don't know all the physics behind it, but of course it was a big pain in the butt to install and get it stable and perfectly level and all this kind of stuff.
Yeah, that's crazy. That's super volatile.
Well, it is volatile in both sense, right? Obviously, it's volatile memory, but then it's volatile from I mean, do not drink the memory for certain.
Oh God!
Right. Do not touch the memory.
Yeah. So, speaking of volatile memory, for your listeners, I was employee number 8 at Sun, right? And the Sun 1 had software-based memory refresh.
Huh.
So you had to take an interrupt every 2 milliseconds or something and walk through a certain amount of memory, or your memory would go away.
So software, in terms like it was the host operating system that was responsible for that. There's not some microcontroller elsewhere. It was actually
or even worse, even when you're booting, you had to get in there very early on and put in an interrupt service for the timer.
Oh my gosh, I did not know that. Every 2 milliseconds. Wow.
Of course, what this made it really hard to do was to put in a breakpoint to debug anything.
You stop the machine and there's no more machine.
Right.
Oh my gosh.
And so that was a feature quickly obsoleted by the Sun 2.
I can imagine. Wow. I did not know that. What a great, was that common at the time to have software refreshed memory?
No, this was an Andy Bechtolsheim special. It was like,
nice.
Why should you have another piece of hardware that increments addresses, blah, 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 when the processor can do that?
Right. And you're like, Andy, is that an earnest question? Because I would like to explain why you would want to have another piece of hardware refresh memory, actually, why we do not want to have those offer. Wow. Yeah. The kind of Andy Bechtolsheim B-sides. That's pretty great. I mean, it's on the one hand, I admire it. I mean, it's classic Andy. I mean, it's very bold.
Right. He was good at saving on hardware, which paid off well.
Wow. In those days, in the Sun 1 days, so you're employee number 8. And you and I didn't overlap at Sun, but you were a folk hero at Sun, obviously, by the time I showed up. I always wish we'd overlapped actually at Sun. But in those days, I mean, you were one of the first software engineers, right? I mean, you were...
Right. I was, I guess, the third actual software engineer.
Wow.
Oh, cool.
but the only one who had really solid Unix experience.
Yeah, I feel like at some point you tweeted out a photo of like a napkin that you had at the time where you just laid out all of the next like 20 years of computing on a napkin.
No, there was a page I have.
Your notebook maybe.
A notebook from the original NFS architecture offsite.
Wow.
Right. And so at the end of it all, we had the drawing on the whiteboard, and I copied it all down to my notebook. And that is the architecture, which is pretty much remains today.
It's an amazing, because it feels modern, and yet it's from 1984?
84, it was, 83 maybe.
83.
NFS didn't ship till 85.
Wow.
So it was probably 83.
I mean, the idea of getting your storage over a network was obviously radical at the time, right? I mean, this is the first real instance of network storage.
Well, I've been doing some research into that, and the notion of a file server was there in the Xerox Alto world.
Right.
And apparently also there in the Datapoint stuff.
Okay.
Which I just finished reading a book about Datapoint.
Oh, yeah. What book would you?
And of course, can't remember the title.
Right.
But it has,
no worries. We'll get it in the show notes. No worries.
But it has Datapoint in it. And they have a strong claim to having invented the microprocessor.
Huh.
Where they work directly with Intel on the 8008. They have a strong claim to inventing the personal computer because they were building programmable desktop devices.
This is pre-Alto then?
Yeah, this is around 1969.
Wow.
And they definitely invented the local area network.
Huh.
Whoa.
Which is ARCNET, which still
survives
in strange ways. Right?
ARCNET. So Datapoint invented ARCNET. I did not realize that. Yeah. Boy, it's let's go read the book. That sounds fascinating.
So they were like king of the business world in the early 80s, and then they had weird management takeovers and blew up in the mid 80s.
Wow.
Well, yeah, many a fate for many a computer company. So ARCNET was invented there. And ARCNET was a bit of a goofy network. I worked at an operating systems company, QNX, that grew up on ARCNET, strangely enough, and supported ARCNET much later than anyone else, I think. It was
basically a token ring.
That's right, it's a token ring, right, yeah. Which, with its concomitant problems, I think.
Right. But it couldn't have been worse than AppleTalk, though.
Oh, interesting. So what, I never had to use AppleTalk.
Yeah.
AppleTalk, not fun?
It was amazing what they were able to do with it, considering it was just a serial port gone crazy. It's actually the same chip that Sun used, the Z8530 UART,
right,
was used on the Macintosh. But because they didn't have to worry about things like multitasking, they could spin loop and drive the thing at 200 kilobits. And that was the basis of local talk. And then they layered on CSMA type stuff on just in software.
With the assumption that you were doing nothing else but driving this UART, basically.
Right. And so at Sun, I did all kinds of horrible magical tricks with UARTs as well. And eventually we had a DMA-based board with that same chip where I wrote an AppleTalk implementation.
There was an AppleTalk implementation for Sun machines.
Never shipped as a product.
Wow.
Because the higher level protocols were even stranger and hard to implement.
The higher level protocols on top of AppleTalk.
Yeah.
So what was even the rationale for even experimenting with it? What were AppleTalk devices? What devices spoke over AppleTalk?
Well, the most notable, of course, is the Mac, but the second most notable was the Laser Writer.
Right. Okay, that's what I was wondering.
Which was Sun actually OEM'd that from Apple.
From Apple, yeah.
But we had to talk to it on a slow serial port.
Interesting. And at a time when the laser printer is not ubiquitous. I mean, it's a very differentiated technology, I remember.
It came from Adobe. They implemented PostScript and all that.
Right.
And their development system was Sun Workstation doing direct DMA to the print engine.
Wow.
Right. Whereas when they ship it, it's a whole separate little system, 68,000 that did all the work. So it was always offensive to me that we were paying Apple for processing inside this thing.
Right. So was the work on getting AppleTalk a way to get Sun to talk directly to the laser writer, presumably?
Well, it was mostly me screwing around.
And learning that AppleTalk was not a puzzle protocol to deal with.
Yeah. What people forget, though, about the 80s is TCP/IP was not a foregone conclusion at all.
Right.
There was IBM SNA, DECnet, OSI protocols, X.25. And I started this group in Sun, the Sunlink group, which eventually shipped like 17 different products, different protocols. all of which are thankfully dead today, right? Because TCP/IP was clearly the way to go, but they're so important to get into a customer site to connect to whatever they already had.
So what made it clear that TCP was the way to go?
In the early days, it was just architecturally superior. You could do a lot more with it. It was happy on Ethernet. It was happy in the wide area, and that was unusual. Actually, I remember people saying TCP/IP will never succeed on a LAN because it's a wide area protocol.
Oh, interesting.
And a few years later, people were saying TCP will never survive in the WAN because it's a LAN protocol.
Right, exactly. Well, you might both be wrong. That is interesting. And this is also, I think it's for those of us who kind of came up later, it's hard to remember or hard to realize that TCP as we know it today really evolved. I mean, it didn't all show up at once, right? Things like congestion avoidance.
Yeah. Yeah, it took a while to sort out a lot of the details, but it's still, I think, will interoperate with off-the-shelf TCP from Berkeley Unix.
That's amazing. Yeah. And that interoperability was really an important strength, I assume.
Right. And just like today, what was important was not the TCP standard. What was important was the fact that Berkeley Unix made it available to everybody.
Interesting.
Because nobody understood the standard, even to this day, right?
So it was the fact that it was effectively open source.
Right.
That was a big part of TCP's success.
Right.
That's good.
Well, I feel that's something that's also forgotten about NFS, that a big part of NFS's success when Sun was an open systems company was actually getting other competing vendors to have a correctly functioning implementation.
Right. And that's kind of a counterexample in some ways, because it would have been easy for us to say, here's the NFS code, just port it to your machine, you're done.
Right.
And that was the easy path if your machine was a lot like a Linux machine.
Right.
So we did license the source code. But there was a protocol spec, and that was actually a very important part of making the protocol work. One of the first independent implementations of NFS was for the IBM PC, which eventually became Sun PC NFS, but it was all assembler, and very tightly coded.
Right. So that is not going to be using the source code from it very much relying on the specification and then being able to but that emphasis on interoperability, I feel was novel at the time. Is that a fair statement? Yeah,
it was fairly new because so many vendors just did proprietary protocols, called it a day.
Right.
At the other end of the scale, people were putting NFS on mainframes that had never seen a C compiler in their life.
Wow. So NFS really became this kind of connective tissue for a lot of these different machines.
Right.
Yeah, it's interesting. And so...
But I have to add that everyone who hates NFS today, you should hate NFS. It means you're using it, A. And B, it's 35 years old, for Christ's sake. We can do something better now.
We can. Yeah, I think there's
you can ask me how later. But.
Yeah, I feel with NFS, on the one hand, I think that, well, first of all, I think a lot of people that think they hate NFS, I'd love to know your opinion on this, they actually hate the Linux auto mounter, in that it is the auto mounter was, because auto mounting is a really important part of NFS, right? It's this kind of like unseen component Sun's auto mounter was terrible and had to be rewritten.
Yeah.
And I've heard no end of horror stories so I think if your auto mounter is bad, you're going to blame NFS. It's like, well,
yeah. So I wrote the very first auto mounter, and it was kind of a toy, but then it got taken over, and all of the generations that I've seen have just been full of all these crazy features where it's clear no one ever quite figured out what they wanted to do with it. So it turned into yet another Turing-complete language.
Right. Did your auto mounter, maybe your auto mounter was the one that worked? We should have kept it simple.
And in my auto mounter, the interface out of the kernel to a user space was just NFS.
Oh, interesting.
Right. So it was very NFS centric. But now, of course, with Linux, there's all kinds of fuse interfaces and God knows what else.
Oh yeah.
Right. Right. And I also think it's just like it's ends up being where the kind of the coal face of cap problems. Many auto mounter problems stem from partitions in the network or transients in the network that are not properly dealt with, that are actually very hard to deal with.
Well, this gets back to people complaining that NFS is not POSIX compatible. And, I like to point out, well, NFS predates POSIX, so what is POSIX's problem?
The problem is that POSIX is not NFS compatible, right?
And the real problem is POSIX says nothing about networks.
Right.
Right. So the cap theorem, which is pretty fundamental,
Yeah.
you have to address it or you don't actually have any semantics on a network.
And I felt that cap was pretty liberating in that we were trying, I felt personally anyway, I was trying to engineer my way around cap for many years.
Right.
Before it was somewhat of a relief to realize, okay, wait a minute. Actually, this is at some level not a solvable problem. That I actually need to pick one of these.
Right. And the other funny thing in the NFS world, originally we just had hard mounts, which is basically from a cap theorem perspective saying that's the only way to get some consistency is to just hang if you can't get it.
Right. We are going to be partition intolerant, effectively.
And then later on, there were soft mounts that said, okay, we're going to go for availability instead of consistency.
Right.
Right. But of course, we didn't understand exactly what was going on back then.
Right. That's what I mean. I think that we were not thinking about it kind of at its more abstract level. And as a result, you didn't have a dial you could turn between like, hey, this is the behavior that I want.
Right.
I want consistency or I want availability. But so that napkin or that notebook, that was pretty amazing to think that in 1984, you ended up basically, that was certainly the next 15 years of network storage.
Yeah, it had legs. I don't know if you know, there was a predecessor to NFS.
Oh.
Network disk.
Okay.
Did you ever hear about this? So
no.
It was a block-based protocol, and it was implemented in the original diskless Sun workstations, where you just couldn't even afford a disk for each workstation. And so it was a very simple read-write block protocol, which shared a disk on a server.
Right.
And people really hated that. And it was very hard to administer because on the server, you didn't have a lot of spare space either, but you had to dedicate all these little slices to all your clients. And so it was a mess.
Right.
But today we have Fiber Channel, we have iSCSI, and they clearly have an important role in the ecosystem, even though, if you're a file bigot, you're a file bigot, and if you're a block bigot, you're a block bigot. But Sun went way out of the way to kill off ND when they did NFS.
Right. Well, probably rightfully so, I think. I mean, I think NFS, all right, and maybe by your nomenclature there, I'm revealing myself to be a file bigot, but there is something that's actually very helpful about having that higher level of abstraction. It just makes it much more understandable what's going on.
Right.
Things
my new way of thinking about this is that files are for people. You can name them, you can move them around. It sort of all makes sense. Blocks are for machines, right? Because the kernel wants to do blocks. And then objects are fine for applications.
Right.
Right. It's just give me something. But you can't ever name them in any interesting way.
Right, in terms of object storage. Yeah. Well, and I think that, I do think this is a great contribution of S3 is realizing that actually not everything needs file semantics.
Right.
Actually.
Right.
There are actually a lot of things out there that are objects that are not going to be mutable.
Well, and to scale to that level, they had to relax the consistency. And so that's another strike against sort of the POSIX compatibility that people want. It's really hard to do that in a very large system.
Right. So going back to the kind of the development of TCP, because you were right involved in that from the Sun perspective, one thing that I've heard about anecdotally, but trying to better understand, is the great internet collapse of 1986. Is that actually a thing? This is the congestion-based, there was no congestion control in the protocols, and the internet was at the point where it could no longer function.
That was pretty much true. I don't remember the particular dates or anything.
Right.
And Sun wasn't on the internet at that point, because that was still very much an academic thing. But we had a lot of customers on the internet. But Van Jacobson came along with the control theorem-based, exponential back off, all that good stuff. So he remains, the hero of the internet.
A hero of the internet, right? Yeah. Well, it really kind of saved the internet from itself, is my understanding, right? That it had gotten to the point that without, congestion control, nobody likes, the metering lights on the bridge because they're the ones that have to, wait for it. But without the metering lights, we end up with actually an unusable internet.
Right. And the alternative to all that was lossless networks, right? As epitomized by X.25 networks, where you gave it a packet and it promised you it would deliver that packet come hell or high water,
Now that
to the other end of the world. And it worked, but it was really slow in lots of cases. And TCP was like, well, send this, we'll retransmit it if it doesn't get there.
Interesting. That must have been a huge fight.
It was. And what's really interesting is Larry Roberts, who passed away not too long ago, he was a really key guy in getting the ARPANET started through, he worked at DARPA for a while, but I forget where all else. But then he went off and started the company that became Telenet, which was the biggest X.25 network provider. And so he was responsible for starting the ARPANET, which all became TCP/IP, but at the same time, his personal preference was lossless stuff.
What was lossless stuff?
He did all this X.25 stuff. And then later on, he did a bunch of router startups that could do lossless stuff. And he was always firmly convinced that was the way to go, even when the rest of the world left him behind.
You can understand the appeal of it, though. There's an engineer's appeal to it that, no, you're going to give me the packet and I'm going to deliver the packet.
Right.
Like, don't worry, you higher level software should not have to deal with having to retransmit or having this thing not show up. I will, but it doesn't, it's hard for it to work.
But see, what they figured out at some point, it was kind of the zen of reliability. The only way to trust a system to be reliable is to not trust it to be reliable and make sure it happens yourself. So tandem computers figured this out very early on. The reason they had such high reliability is they forced application writers to not trust the hardware or the operating system.
Huh.
And so with Ethernet, it says, hey, it might get there, it might not, just don't trust me. So and you have to build protocols that work on top of that.
It's kind of a deep thought. I don't know about
Jess.
I'm going to need a moment on that one.
This
is like a variant of the only way to win is not to play. Like the only way to actually get reliability is to understand the inherent unreliability in the substrate below you.
Right, and it forces it back on the application, which can then make intelligent trade-offs about what it really needs to do or not. And this is invading my life again these days in the form of Ethernet fabrics versus PCI Express fabrics.
Right.
And,
what do you make of all that?
Well, PCI Express, it's a bus, right?
Right.
And the thing about the bus is the operating system and the users and everything assumes that bus is the heart of the system. It's always going to work or just nothing is going to work.
Right.
And so it's you inherently expect it to be reliable. But now you take it out of the box on some cable that's liable to be tripped over and bad things happen.
Yeah, it feels to me like why are we making the bus into a network? Since I do feel like the contract is very fundamentally different.
Right, but making the network into a bus, turns out, improves reliability in all kinds of interesting ways.
Okay, interesting. Wait, could you expand on that? That's interesting.
Another example, we've worked a lot with SAS, serial SCSI at drive scale, which thankfully is not as central anymore. But it's another one of these, reliability built in at the link layer kind of stuff. And we've seen situations where a dying disk will take out all the other disks on its SCSI controller because error recovery was so central to everything. And we don't want that to happen. We just want the disk to die and leave everything else alone.
Oh, interesting.
When you go down that slippery slope of promising reliability, you have to account for every possible error case that might ever happen, which is also impossible because you don't know. Whereas with best effort, it's like, well, it usually works. And when it doesn't work, give us a call.
Right. So where does that land you then on these PCI-based fabrics, network fabrics? I mean,
I'm against them.
Okay.
I mean, they're
I felt, okay, good. I wanted to make sure that.
But on the other hand, there's about 100 AI accelerator startups right now.
Right.
Right. They're all building PCI Express based chips.
Right.
And our whole thing at DriveScale is that we're trying to make servers simpler and get stuff out of the server. Right. So PCI based fabric is a way to do it, but it really doesn't go very far.
Well, it just seems like, PCI obviously doesn't have to deal with partitions. PCI is able to be a cap denier. And yet, the second you go over as you say, you get a cable that someone can trip over, it's like, welcome to a partition.
Yeah. And then you get into, well, can't I have two cables in case one goes out? And then
Here we go.
Then that's a whole different kind of network architecture.
Right. And now you got to deal with the things from miscabled and everything else.
Right.
I mean, that's really that's the power of Ethernet, right? Is that you could just kind of plug it in and go.
Yeah. And routing protocols figure stuff out.
Right.
It's all kind of plug and play, right?
All right, we're going to take a quick break, and then we will be back with more Tom Lyon on the Metal.
On the Metal is brought to you by the Oxide Computer Company.
Wait, did you say computer company, Jess?
Yes, indeed.
But wait a minute, everyone runs on the public cloud. Jeff Bezos owns and operates every computer on the planet. Why would anyone start a computer company?
That is so not true. I have spent a bunch of time talking to folks who are still running on premises, and actually, like, the consensus among all of them is just a feeling of neglect because everyone thinks that, like, everything is moving to the public cloud, but it's not.
If you're still running on premises, it's because you haven't heard of the cloud, right?
No, there are really good reasons for running on premises still. For security, for latency, strategic reasons for your business.
Wow, the people running on premises must feel like everyone has ignored them.
They do, indeed. So if this is you, please head on over to our website, oxide.computer, sign up for our mailing list, and we would love to get in touch and hear your stories.
We acknowledge that you exist and you've got some really hard technical problems that we're solving. Oxide.computer, come join us. And we're back. All right. So, Tom, we left off. We were talking about Ethernet. Ethernet was effectively not only brand new, but one of several competing kind of networking substrates back in the day, right?
Actually, everyone knows Ethernet by the more formal name, IEEE 802.3, right? And 802.1 is management protocols, which are still used. But there was an 802.2 and an 802.4 and an 802.5 and an 802.6, which I have personally implemented all of those.
Oh, wow.
802.7 and beyond, I forget what all they were. Some of them were wireless, 802.11.
Yeah, right. I mean, I feel like I only know 802.11. I don't know. The
802.5 was IBM Token Ring.
Yeah, I did not know that one.
Yeah.
And that was a huge contender for a long time because
Right.
IBM was pushing it. And I personally wrote token ring drivers. I have a whole token ring story if you want to go there.
This is what we're here
why
for.
we're here. Let's do the token ring story.
Okay, so in 1989, Sun is pretty hot. IBM shows up at Sun with their new 16 megabit token ring adapters for the PCAT bus.
Okay.
And they say, we're announcing these in 2 weeks at the Comdex show. And, if you guys want to be part of this somehow, here's a couple of boards.
In 2 weeks.
2 weeks.
Okay. Thanks for the advance notice.
Now, at that time, Sun had not only the Sun 3 family with 68,000 base, but the Spark family had just been introduced.
Right.
Sun 4 based. And we had the Sun 386i, which was 386 and PCAT bus. So all we needed to do to show this off was to write a driver.
Right.
So I did in 2 weeks, and it worked great.
Nice.
So we get to the show. We're demoing TCP/IP and NFS on Token Ring, 16 megabits between Sun 3s, Sun 4s, and Sun 386i. And the Sun 4, one of my friends did a hardware hack where he hacked up a VME bus to PCAT bus adapter. So we had the Sun 4 on the Token Ring.
Hacked up a VME bus to AT bus adapter in 2 weeks?
Right.
Okay.
Those were the days.
Those were the days. How did you hack that? How does one hack that up in 2 weeks?
It was, I don't know. It was awesome. So anyway, I'm at Comdex. I'm dressed to the nines because, it's a trade show. I brought up my suit. So I'm in the booth. I'm explaining, and somewhat sleep starved from having written a driver for the past 2 weeks. I'm in the booth explaining all this to some guy, blah, 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 blah. And the guy says, wow, this is really interesting. Is there anyone more technical I could talk to?
Wow.
Wow. Purely because of the suit.
Right.
That's crazy.
Wow. You're like, look, pal, I've been writing the driver for the last 2 weeks. I'm not sure there's anyone more technical on the planet in this domain right now. That is great. How did you take that?
I was like, I was just stunned. It's like, no, there isn't.
Right. I was like, wow, geez, God, I had to talk to some suit at the trade show. That's great. And did the token ring, did that sell? I mean, were people, I remember those days when token ring was, it was obviously an IBM push standard. It's a big deal.
Yeah. So we actually did a S-bus token ring board.
Interesting. You're right.
After that. And that was relatively important. In my next company, Epsilon, where we did IP switching and ATM networking, we ended up doing token ring interface as well, because there's just a lot of it out there.
Right. Interesting. And there's certainly an appeal to it. Do you know anything about token? We should probably explain token ring a little bit.
Yeah, I don't know anything.
Yeah. So Tom, could you just give it a quick explanation of how token ring works?
Well, it's best to understand relative to Ethernet. So Ethernet, in its original days as a shared medium network, it was contention-based, so people would transmit, and if you're lucky, nobody else would transmit at the same time. But if you detected somebody transmitting at the same time, then you would back off a random amount of time and try again. And people looked at that and said, "That's complete chaos.
Crazy, right?
Could that ever work?"
Right.
Whereas token ring, it was very orderly. So it was a polling system, and you passed a token around from node to node to node, and everybody took their turn and could add to the token with their message as it went around.
And you would know, if I recall correctly, you would know when everybody on the ring has seen this message. When I have now received my own message, I know that everyone has seen my message.
Right.
So there's something to be, that's nice.
Yeah.
You know,
I mean, you can always depend on people getting the message because they could be booting or something while that's happening.
Right.
But yeah, it was all very orderly. And there were quite a few systems. We mentioned ARCNET before. IBM had theirs. There was Proteon, which very early on had a 70 megabit network that was token ring. And then there was FDDI, which was optical based, 100 megabit, and that was all token ring based.
Right.
But all different types of token rings.
And so why did token ring not win?
Again, it's complex because token ring, it's all very orderly until somebody loses the token.
It loses the token, right? This is always the knock on token ring, is that it would someone would spill the token on the floor.
Right.
And now
I think Dilbert has a cartoon to that effect.
Right.
Yeah. And then you get into the error recovery procedures, which were more complex than all of the Ethernet spec in the first place.
Oh, geez.
Interesting. Right. And presumably not well tested.
Right.
Yeah.
And very, very complicated. So you ended up having to have a lot of smarts on your controller instead of a dumb piece of hardware, that kind of stuff.
Right. And then how open was token ring relative to Ethernet? Or were they?
It wasn't as open as early, but by the time they did the IEEE thing,
They kind of figured out.
perfectly open.
Right.
TI had chipsets anyone could buy, that kind of stuff.
Right. And I remember FDDI, I mean, was still around and still performing and competitive with Ethernet as late as, was as late as like the 2000s, early 2000s.
Yeah, certainly. All through the 90s at least. A lot of the internet exchanges were built on FDDI switches from digital, stuff like that.
Right.
So what happened to it? Why did it die? Or is it still around and I just don't know it?
I mean, it's obviously still around somewhere, but I think Ethernet ultimately just rolled it with the economics.
Yeah. There was a company, Crescendo Systems, that built a 100 megabit physical layer for twisted pair.
Okay.
So they're the first ones to do 100 megabit at twisted pair.
Right.
And they developed it for FDDI.
Huh.
But then Cisco bought them and said, we can do Ethernet with this.
Right.
Right. And that was kind of the end of FDDI.
Right. As it would, because fiber is such a pain in the butt to deal with. So it's great.
Yeah.
Until you actually step on it, or
Yeah. So, and certainly at that point there was still, data centers were nascent, right? So you had a lot of wiring, through the physical infrastructure. That was really hard to deal with fiber.
Right. And you could get presumably longer runs with fiber than
with single mode.
Right.
But mostly people were still doing multi-mode.
Multi-mode. Okay. Interesting. And so anyways, Ethernet takes over, and you left Sun. Actually, could we go back before Sun a little bit? Because I would love to know what your first machine was. How did you get into this?
So my first machine, my dad worked for the local power utility, and my aunt was a professor at the university in El Paso.
Oh, wow.
One day, my dad came, he took a trip to IBM in San Jose because they were looking at buying a computer to help run all the operations. And he came home with a Fortran manual. That was the end of life as I know it. And also for several of my brothers. So we're like, what the heck is this thing? And then it turns out my aunt could get us access to the brand new computer at the university, which was a CDC 3100.
Oh, nice.
It was a low end of the CDC range, but a 24-bit machine.
Right.
With ones complement arithmetic.
Oh, wow.
So there were two kinds of zeros, positive and negative.
Right. Yeah. An idea that died for a lot of good. Two's complement, as it turns out, really is a better way to actually do things.
Yeah. And so that was 1967 when I started. I was in 6th grade. And really
devouring it. So you had a Fortran manual, but no Fortran compiler up until you got access via DRAM, right?
Right.
So this is all theoretical Fortran.
Well, it was just very interesting. And of course, everyone had heard of computers at that point. They were still mysterious things, but somehow I just got sucked into that.
That's great. And then when you went to school, did you know you wanted to go into engineering in some capacity?
Yeah. I mean, I come from a very nerdy family, again, because my dad was an engineer and Renaissance man and could fix anything, blah, blah, blah. And we were very competitive academically among the 7 boys and 2 girls.
Oh, wow.
I did not know you had that many siblings.
That's a lot.
Yeah. I did not know. I mean, obviously you've got siblings of note. So I knew of the Lyon brothers, but I had no idea that there were 9 of you.
Yes, we're everywhere. And two of the siblings ended up non-technical stuff.
7 of the 9 ended up pursuing technical.
That's crazy. That's also really cool.
That's amazing. Wow.
And so even now I have a brother at Google. I call him the smart brother. He wrote a whole book on hearing, machine and human hearing, and I literally cannot get through the first chapter.
Whoa.
And a brother who's been at Microsoft for 25 years now.
Oh, wow.
Wow.
It's just like distributed.
It is, yeah. That is amazing.
And my brother Bob retired early from his Legato startup experience.
Right. And I think Bob is the Lyon brother that I had heard of.
He was also at Sun.
He was at Sun, right.
He actually managed the NFS group.
Right, okay.
Whereas I was just part of the NFS architecture crew. I didn't actually implement anything.
Did you ever have to report to your brother?
No.
Thank God, right?
I was part of it. I didn't want to do it. So
yeah, right.
That would be weird, yeah.
Yeah. It's like, why are you hitting yourself? It's like, God, I hate my one-on-ones with you. It's like, stop. Wow, that is odd.
Anyway, so through high school, I got into every computer I could find in El Paso and had a number of odd jobs doing programming and stuff.
So it's the 70s. Computers are becoming more, high schools probably have computers at this point, right?
Yeah, mine didn't. Mine had a programmable calculator.
Right, okay.
But the tech high school in the school system had an IBM 1130.
Okay.
So I spent a lot of time on that.
What was the programmable calculator? Do you remember?
It was an Olivetti Programma 101.
Nice.
So it was pretty nice for a programmable calculator.
Because I feel
about big.
Right. I feel some of the first programs I wrote were for a programmable calculator.
Yeah.
And
Monroe was the other big name, I think.
Okay. I mean, I came up on, by the time it was HP for me, by the time I was programming calculators, it was the Olivettis, I think, were gone, and they were not, a yard by a yard.
Mine was like way later.
Right. You're TI 89.
83.
83.
Please. Okay, I'm not that bad.
Okay. All right. I just said
I'm like offended.
I'm so sorry. Yeah. But there is a certain class of nerd that has that first calculator love. That's good to know. So Jess,
I still have one.
It's good to know that. All right. So Jess is not so young, but Jess, you should know there are people, the generation behind you, I don't think their first love is a calculator. Yeah, I know.
How could this be?
It's tragic. I mean, the TI-89 is still very entrenched, and it's galling when you get the high school course that mandates it. And I think they want like $120.
They should ban that thing because honestly, you can do way too much with it.
Oh, you can definitely do way too much with it.
You can just do straight up integrals.
Oh.
Yes.
By plugging in the numbers. Like it's cheating.
It is cheating, and I had an HP 48, a 48G that I had used all of my summer money to buy, that I actually took in a linear algebra course where the prof did not understand that the HP 48 could basically take the exam for me. And he foolishly allowed us to use calculators on an exam.
No, that's why I said that they should be banned.
Yeah.
Or show your work.
I remember when I was in high school, it was probably 73, the HP 35 came out.
Okay.
Which was the first seriously powerful, handheld, scientific...
RPN, presumably.
Yeah, RPN. That was awesome. My brother brought one home from Caltech where he was going, and I had already mostly disassembled it, but it still worked.
Oh, that is great. And so where were you in the birth order then? You're obviously not the oldest.
Yeah, 6 of 9.
6 of 9. Wow. Wow, that is that's amazing. And then what is the age spread between you and your oldest sibling?
Between me, my mom really pumped them out in the early years. So the first 6 of us are 7 years.
Oh, wow.
Wow.
Yeah.
Okay, so that was like just like one right after the other.
Then there's after me. There's a 3-year gap to twins,
Okay.
Oh, whoa.
boy and girl.
Yeah.
And then there's a 8-year gap.
Okay, all right,
to
there
my
we go.
youngest.
There's got to be one of those that
Because after twins, I feel like you're like, okay, we gotta hold off for a little bit.
We gotta lay off. We gotta.
So the youngest one was clearly a surprise.
Yeah, exactly.
And my oldest brother had gone to college when he was born.
Right.
So that's a big spread.
That is good. But wow, so you had 6 kids under the age of 7 at one point.
That's really intense.
That is and most of them apparently destined for tech.
And my dad had like 3 jobs because he had the power utility and he was repairing TVs and radios on the side and all this stuff.
Oh my gosh.
Oh, wow.
Teaching some.
But there must have always been stuff around to play with. Obviously, there was the Fortran manual. Obviously, came home. The Fortran. So you can imagine the Fortran manual coming home to this wolf pack of future technologists.
Well, I think
just being devoured like carrion.
I sort of remember a sense of disappointment when I figured out that my dad wasn't going to just make a computer because he can make everything else.
Right. Wow.
Yeah, that was my impression.
That he was going to make a computer. I do think, and this is where, and Jess, I know you are definitely not too young, that generation of really longing for a computer.
Oh, yeah.
Like I want to have a computer, but I can't have one.
I saved for a long time for like my own personal laptop. So,
Right.
And then I used like some of my bat mitzvah money, which I wasn't supposed to do, but I did.
For a computer.
Yeah.
Yeah. And I feel like that, I don't know, I think it's a bit lost, unfortunately.
Yeah, it's funny. I completely missed the personal computer, the home-built computer phase.
Okay. Because that postdates you effectively.
Well, no, it's mostly I was always so deep into computers.
Right. Yeah, that's what I mean. Yeah.
I had the real computers.
Right. Right.
So I had my day job at Amdahl working with mainframes.
So Amdahl, was that your first job out of school?
That was my first job out of school. Yeah.
Wow.
Porting Unix to the mainframe.
Oh, nice.
And then there was Sun. So, and one of the things that set Sun apart was that the technical founders all were coming from bigger computers. So we knew that computers were actually supposed to stay up for more than an hour.
Right.
Whereas there's a huge homegrown community building everything you can imagine in Silicon Valley. There were literally 168,000 computer startups.
There were 168,000 startups.
Just like 100 AI chips today.
Right.
Crazy. There are a lot of AI chips.
There are. So that's the Halt and Catch Fire era. That right there.
Right.
That's dope.
That's a great show, by the way.
It is a great show,
That
right?
is one of my favorite shows. I watch it all the time.
And one of the mind-blowing things is Carl Ledbetter, who's on our board at DriveScale,
Yeah.
was technical advisor to that show.
Oh, well, that's great.
That's why it's so good. Like, there's a lot of little details in it where, like, you know that they have someone involved that's like super smart.
He did a great job on that.
This is where, though, you do have to say that. So Jess was a technical advisor to HBO's Silicon Valley, which is also pretty cool.
Which they also took super seriously because they don't want to be blown up on Reddit, which I could see why Halt and Catch Fire would be the same way. Because the second you get blown up on Reddit, like everyone, it's done.
Right.
Like,
You take your job very seriously.
yeah. No, it's scary.
Silicon Valley is hilarious. I love that.
So your job was to make sure that the Go compiled, right? That the Go
Well, so
would
it didn't
flash on
technically
screen for a
have
second.
to compile, but I made it compile because I was like, if it flashes on screen for a second, it's like incompatible code. Like I will be mad at myself more than like they would possibly be mad. But like if it blows up on Reddit, then I'd super be mad at myself because I'd be like, it needs to compile.
Now, can I ask you a very personal question though?
Yeah.
Tabs or spaces?
So Go has Go thumped, but like, so they do whatever, and I think it converts it to tabs. But when I do bash scripting, I have been forced into the tab life because of TAnon.
Oh, okay.
Yeah.
So because I mean, by the time you and I were working together, you were already hard tabs. So I
had to switch my Vim settings because we couldn't both contribute to the Docker like little scripts in the repo because he'd always be like, you're doing spaces again. And then I'd have to like go fix it. I was like, I'm just going to fix my editor.
Just do hard tabs. Okay. So Tom, how old is that? Is that debate? Hard tabs versus spaces?
Not that old from my perspective.
Okay.
Because there was a time when you used tabs because it saved a lot of space, in storage.
That was the actual rationale.
And in communication, right?
Okay.
And the early Unix days was, like the 110 baud TTY 33, you didn't want to mess around sending spaces when you could send us a tab.
I send a hard tab. Okay. Because I mean, truthfully, I feel that my own bias towards hard tabs, certainly in shell scripts, just kind of comes up with the way I came up, and I came up in the source base that you were in. I came up in Sun's Unix, effectively.
Yeah.
Where it was hard tabs. That was what I was accustomed to.
Yeah. No, if I'm doing C, it needs to be tabs, and then when I do Python, it's been beaten out of me. It needs to be spaces.
Yeah, I feel the same way.
Python people are very actually intense about spaces.
I kind of feel like the on white space. Yeah, you thought you were listening to On the Metal. You're actually listening to On the White Space, our alternate podcast on the white space, tales from hard tabs and soft tabs. I feel that you just got to go with the prevailing culture in the community you're in.
Right.
And that it's very helpful to have Vim settings that say, okay, if this is a Rust file, if this is a Python file, if this is a C file, I'm going to change my defaults. That's actually very helpful, I found.
Yeah, it's gotten a lot easier with editors that can be programmed.
Yeah. Editors that can be programmed without actually consuming all of the resources on the machine. I assume you've got to be a VI guy.
Right.
Yeah.
I'm an ED guy.
Hey,
nice.
old school. There we go.
It's in my muscle memory.
That is awesome.
I survive in VI because it's all buried in there somewhere.
That is awesome. I'm certainly one of the tribe. Where you do you use ED? You've used?
I've tried it, but like that, like Vim is so ingrained in me that I can't use anything else.
I'll tell you that the experience that for me really got Ed into the muscle memory was over a serial line. If you're over a serial line and you need to edit a file, like that will get the VI right out of you. You'll get very accustomed to. And ultimately the Emacs got out of me because I showed up to a job and all I knew was Emacs. And I ended up spending the first 2 days trying to get the goddamn editor to compile as opposed to just using VI. Of course, I was also in a workplace that called it VI.
Right.
Which is, I think that's a Canadian thing. It was very weird.
Oof.
I also came back from that job saying process and resources. It was really corrupting in a lot of ways. You know, it was a problem.
For someone who you give a lot of shit to for pronouncing things wrong, like I like am basking in this moment right now.
No, you should. If you catch me saying Vi, you should jump all over it. That
I
would
might
not
say
be
it
good.
just to like make it cringy.
Yeah, no, it's yeah. But so you used ED probably for actual like real editing back in the day.
Oh yeah, and I started at Princeton, so we got a Unix system when I was a freshman there, Unix version 6.
Okay, 6th edition.
And that was what you had for editing.
And that was on, is that a 3B2 or is that too early for a 3B2?
It was too early. This was a PDP 1145.
Yeah, there you go. Yeah.
And then through an interesting series of events, I started trying to port Unix from that PDP 11 to the 370 at Princeton.
Oh, interesting.
And that was a...
Okay, what is the interesting series of events? Because that's got to be very early for Unix on the mainframe.
Yes. In fact, I think it's come out recently that was the first Unix port ever attempted.
Wow.
Whoa.
As opposed to stuff like moving from the PDP 7 to PDP 11, which was a rewrite.
Rewrite, yeah.
And it wasn't the first to be successful, but it was the first to start.
Spoiler.
Yeah. So my freshman year, the Princeton Computer Center, where I worked for all 4 years, so I had arbitrary access to stuff. They operated a time-sharing APL 360 system.
Oh, wow.
For the state of New Jersey and all the colleges. And APL was incredibly cool system, incredibly powerful, and only understandable by people from ancient, strange civilizations.
And this is APL, the programming language, right? I mean, so this is
But APL 360 was an entire time-sharing system that ran in lieu of other operating system.
Wow. And would run only APL programs? Or
Right.
And APL is a first class. And so do you have the APL keyboard?
Yeah, you had the best thing to have was these IBM Selectric 2741s with the APL font ball, and it was all built around this whole thing called visual fidelity, where if you overstruck an F with an L, capital F with capital L, it would look like a capital E, and in fact would be taken as a capital E by the system.
Okay. Wow.
I mean, it was full of weird, strange things like that.
That is delightfully strange. Jess, have you ever looked at APL?
No.
Oh my God.
Don't take this as a value judgment, but you would love it.
Okay.
It is super information dense, and it is. I mean, its origins are really in math. I mean, it's
so is that like K?
K.
Yeah, K is a successor of APL.
Okay.
K is an APL descendant,
Because I liked K.
but
it's crazy.
It's crazy, but true APL
has its own character set.
Its own character set.
Right?
How do you type that?
Because this was
glad you asked. On an APL keyboard.
On an APL keyboard. Because this was pre-ASCII. There's no standards.
That's crazy.
So you have programs that are like 3 characters long that are meaningful.
Right. And it's a very large character set as well. So
whoa.
There's all these symbols, all the Greek letters, yada, yada, yada. They all have...
Okay, so it's like K, but on steroids.
Right.
I would say K is like APL trying to get like toned down.
Okay.
So, all right. So you're on APL 360.
Yeah. Anyway, so that system, the state of New Jersey decided to shut that down. And so Princeton was going to be left without a time-sharing system. And that was clearly not acceptable. So a bunch of us who had been using the Unix system said, well, the computer center should get a big PDP 1170, open up a time-sharing system for the whole campus. Yeah. And the computer center's reaction was, what the heck is Unix? What the heck is a PDP? And oh, by the way, we just talked to IBM, and they're going to give us another 370 because Princeton was a very high-profile site for IBM.
Right, I can imagine, yeah.
So we ended up with an IBM 370 running VM 370, where virtual machines came from.
Right.
Which is another whole story. So the Unix gang was disappointed. It was like, grumble. But, I said, well, wait, Unix is written in this C thing, right? And that mainframe has virtual machines. Why don't we just recompile it and put it over there?
It's just software.
Just software. And so everyone had a good laugh about that. Until, and that was like in the spring of 75. And then in August, while I was home from school, I got a call from Eric Schmidt. Now, Eric Schmidt was one of the Unix gang and advocating for stuff. So he had heard me say, why don't we just do this? But then it turns out he got a summer job at Bell Labs working with the Unix group, famously working on Lex. And he discovered that there was a 370C compiler at Bell Labs. So he said, well, that's clearly what we need to make this happen. So he calls me up, says, Tom, are you really interested in doing this? We can arrange a project. I said, sure. What do I know?
And just to be clear, this is the Eric Schmidt.
The Eric Schmidt.
Wow. Okay. So you got the C compiler now. So this is now possible.
Right. And so we get the C compiler, then it's a mere matter of hacking away at things. And there was Eric Schmidt who kind of organized things and arranged for us to get credit for the work and all this good stuff.
So Eric, I knew Eric was at Sun, but I didn't know that he was at Princeton.
At Princeton, 2 years ahead of me.
2 years ahead of you. Okay.
Yeah.
Wow.
So he organized a lot of stuff. And then there were 3 of us who actually did technical work. And the other 2 guys were also 2 years ahead of me. So after 1 year, we had not got very far, and they all graduated. And then the second year, I managed to get to the point where I could demonstrate a shell and a kernel on the mainframe. But it was very badly hobbled by the networking or lack thereof between the PDP-11 and the 370.
Okay.
Which, if I recall correctly, the PDP-11 had to talk to a PDP-8 on a unibus. The PDP-8 was attached to a serial line, which ran about 10 times further than any standard could ever support, down to an IBM 360 Model 20, which was a satellite processor for the big 360 in the computer center.
Okay, so how far is that serial line running?
That serial line was...
I'm getting like hundreds of feet, it sounds like?
It's about 300 feet.
Okay, wow.
So sometimes it works, sometimes it was
exactly.
It was just line noise.
Oh my God.
And nobody really understood how or why.
Right. I mean, it's a serial line running the length of a football field.
That's
right.
Really...
Yeah. And at that point, I was a pure digital guy. Software. Don't talk analog to me. I have no idea what any of that means. So it was all a mystery to me as to why this would work or not work.
Right.
But anyway, once you got to the 370 world, everything had to be card images. So you'd have to submit your deck of cards to the mainframe, which could eventually route it to the time sharing system, which then had a virtual machine where you could suck it in as pretend cards and try something. So it was like an hour to get it from point A to point B.
So you're doing your work on that PDP-11,
right?
Going to the PDP-8, going over to the football field length serial line,
right.
Dropping any number of bits along the carpet on the way,
right.
To the punch cards, into the system and then like doesn't compile. Presumably you would.
Well, I mean, we compiled on the
exactly.
on the PDP-11,
Sure you don't have that mistakes.
But we had to do the testing
the
hard way.
Right.
So it was slow and painful.
Yeah, that is a slow and painful dev loop for sure. But you got it, even in that, you got it working to the point where you could had a shell.
Yeah. So it got to the point where I could demonstrate that fork actually worked. And it's like, hallelujah.
Nice.
That was it.
Wow. And so did that experience help get you the job at Amdahl?
Oh, yes. So there's a whole series of serendipitous events here. So I wanted to work at Bell Labs for the summer. So I go through the normal interview processes. I end up interviewing with this guy who was doing something with Unix, but it wasn't the research group. And for whatever reason, he invites Ken Thompson down to impress me at lunch. Right. So Ken Thompson and I are having lunch with this guy. And I start talking about this work I've done porting Unix to 370. And Ken is like, holy cow, we're just about to start porting Unix to the Interdata.
Oh, wow.
All right. And
Ken's, so mission accomplished on, instead of Ken impressing you, you're impressing Ken.
Right. So totally serendipitous. So Ken stole me for the rest of the day. And I ended up working with the Unix group for the summer.
Oh, wow.
That's awesome.
And that was the main work, converting V6 into the portable V7, which ended up everywhere.
Oh, so you're working in the Unix group in the summer of like 75, 76?
77.
Wow. That is,
That's
okay,
cool.
So now here's the other serendipitous thing. So Ken had spent a year at Berkeley, I think 75, 76, and made some friends. One of those friends, this guy named Denny Koch, ended up working at Amdahl. And then he was agitating, we need to get a decent time-sharing system in here. And at one point, I'm literally sitting in the Unix room with Ken Thompson. Ken gets a call from another guy at Amdahl. This guy at Amdahl is asking Ken, so we hear rumors there's it could be a port somewhere of Unix for a 370. And Ken says, Tom, it's for you.
Wow.
So I ended up working for them.
That's amazing. So, all right, we got to take another quick break, and then I got so many follow-up questions. So we'll take a quick break, and we'll be right back with more Tom Lyon.
On the Metal is brought to you by the Oxide Computer Company. Well, bad news. I just got back from a meeting with the attorneys.
Oh, boy.
They are not going to let us say much in these ads. We can't talk about the customer experience today for on-premises infrastructure.
So we can't do my idea to be like, are you being gaslit by your vendors? Because that's what they're doing. They are gaslighting people into thinking that these bugs only exist on one of their machines when it exists on like everyone's.
God, no. They called that, I think, quote, a third rail.
They must be following Jess on Twitter. I knew that was a bad idea to let the lawyers follow Jess on Twitter.
They also said we can't talk about public cloud customer experience.
Oh, come on. We can't talk about the rapacious bandwidth pricing? It's practically criminal.
No, can't talk about the unit economics of that at all.
Can we use the word criminal with respect to public cloud vendors?
Definitely not.
Oh, boy. What can we do?
Well, they did say, they gave us a statement we can use, which is...
Are you going to read from it?
Oxide Computer Company is building something that should help some people.
Well, that seems very direct. Come on. Can we at least send them over to oxide.computer?
We can. The other bit of bad news is all the lawyers were there in the meeting.
Oh, wait a minute. Not just the cheap one, but the expensive one?
Yeah, they were all there.
So we paid a fortune to get this terrible ad. Oh my God. Please, listener, go to oxide.computer and learn what we're actually doing. All right, we're back. Jess, I don't know about you, but I got a ton of follow-up questions.
No, that's totally cool.
This is because boy, if you gave me a time machine and allow me to set the dial anywhere, I might set it to Bell Labs.
I would definitely do that.
You've got so many interesting folks, such an interesting collection of people.
Right.
And you're there for the summer, basically, as a summer intern, effectively.
Right. It was mind-boggling. But yeah, Bell Labs in its heyday was incredible. They hired something like 30% of all PhDs in the U.S.
Wow.
Whoa. That is a lot of PhDs.
Yeah. And an awful lot of other people. Like the same summer I was working there, my brother Bob, who's 1 year older, and his wife Linda, they had both just graduated from Cornell and started working at Bell Labs also. So I was in Murray Hill. They were in Homedale, but I would take the Bell Labs bus over to see them for the weekend, that kind of stuff.
Right.
That's cool.
And they were on the OYOC program where you get sent off to get your master's degree paid for by Bell Labs. And they both did that, and they were like living like kings because they both had half their salary while they were getting their masters and all this.
Right. Not living the typical grad student life at all. Right. That's great. I mean, there's so many incredible people there at that time doing so much interesting stuff.
So directly across the hall from me when I was there was Greg Chesson.
Right.
Did you ever know Greg?
I did not actually know Greg.
So he was an amazing person, always the funniest guy. Super smart. He contributed an awful lot to SGI. That was his main purview. But he was doing networking back then, although it was very strange, pre-ATM kind of stuff.
Right. So this is, network. What does networking even look like in the 70s?
Yeah. Well, his stuff was very weird, and this data kit, I never quite understood it.
Oh, interesting. And so then you head to, so you're with this amazing collection of folks. Was Joseph Osana anywhere near you by any chance?
Yes. So Osana was part of that crowd.
Can I ask you a question that never got resolved? He died shortly thereafter.
Right about the same time, yeah.
Do you know how he died?
I think it was a heart attack.
That's okay, yeah. I've heard both a heart attack and a car crash, but he died suddenly.
Yeah.
And it was my understanding that he had written a bunch of, because he wrote the original NROF, right? Or ROF, maybe.
Or
was it T-ROF?
T-ROF, I think.
Okay.
Brian Kernahan just came out with a book that explains a lot.
Okay, I need to go read. I've not read Brian's book. I need to go read it because because supposedly, according to lore, Brian went into Osana's now deceased, and went into Osana's code to actually because the code had been ported to the C from assembler.
Yeah, so I have some personal view there because I was busy porting code, cleaning up code so it would port between the PDP-11 and the interdata, right? And it was little endian, big endian, 16-bit, 32-bit, a lot of differences, right? And so I open up NROF. I'm like, what the hell is this?
It is amazing. And we still have the NROF source. NROF source is out there. You can go look at the NROF source. And it is really like KK or equals octal 13. If YY octal and octal, it's just like, it's all magic numbers. It's all.
And it was clearly derived from assembler.
It's clearly derived from assembler.
Where they were just doing word-based stuff. They didn't care. They were very loose with types if they had any, right? And everything broke moving to big endian from that.
Oh, I can only imagine.
And so I just threw up my hands and said,
someone else
above my pay grade.
Right, exactly. Well, and I have to go see if he talks about it in his book, but Brian supposedly went into that code being like, oh, come on, it can't be. Come on, it's software, people. Like, how bad can it be? Like, I'm going to go modernize this.
Yeah.
And came out being like, I do not understand how this thing is working.
Oh my God.
But he made it portable at some point, so.
Yeah, God, it's portable. Him. Well, this is and the thing that when I first heard that story as an undergraduate, it was being handed out from actually someone who was at Princeton. I don't know if you know Tom Deppner at Princeton, but he would have been at Princeton a couple years behind you. But my professor at school that had described this to me. And as I realized that this code was still very much in our source base at Sun, you realize that this is something that was written in the 70s that is going to survive long past all of the hardware that it was originally built for. That the software has this incredible permanence.
Right. And the basic idea ROF came out of runoff from the CTSS system, which is like the original time sharing system ever. And then Brian Kernahan was a student at Princeton for a while. He wrote a version of it for the IBM mainframe there, which saved my ass many times because that's how I wrote all my papers when I was at Princeton.
Oh, really?
But it was all card based, right? But
so you wrote your papers in the IBM mainframe version of ROF, effectively,
and it was beautiful because you could shrink the margins all you wanted and blah blah blah. So you could always stretch that thing out to meet the minimum size. And
you think, Jess, you're a LaTeX nerd. This is like, I think Tom just saw you and raised you to you got to go like raw ROF if you really want to nerd it out.
Okay, I'll try that.
Well, that's the original language of man pages, right? The man pages are written all in.
Yeah.
That's pretty readable.
Yeah.
Well, but man pages have macros.
That's right.
I don't think ours had macros.
Oh, that's right. There you go. Macros. Oh, the kids today and their macros. Let me tell you, that is great. So you did, now at that time, you are, and then how are you're typesetting them? How are you printing them? What are you printing them on, your papers?
You print them on these giant IBM line printers. The IBM 1403, which came out with IBM 1401 computer around 1959.
Right.
That thing is amazing. 600 lines per minute with these crazy print chains. You could swap out for different fonts. You can do different spacing and
600 lines per minute.
So you send out this direction, say mount the pure white paper, please.
Right.
And out spews your thesis or whatever.
So the IBM 1403 dates back to the 50s, obviously.
Yeah.
Late 50s, early 60s. Yeah. And it's going 600 lines per minute.
Right.
10 lines a second.
Creating a terrific racket. And they have one fully restored now at the Computer Museum.
Oh my God. That must be mesmerizing.
Yeah. And they even found one of the original IBM engineers to help them out with this crazy print chain thing.
They may have needed it. I mean, because it must have felt like this thing fell from space. So you turned in your papers for your English class or whatever.
Right.
Did your professors in these other classes treat you as an alien from the future? I mean, this must have been, surely you're the only one.
Well, it had been going on for a few years.
Okay.
Right? So I got a few funny looks, but you're supposed to typewrite things, right? So it's not always immediately obvious. What the difference is.
Okay.
Right. But
that's amazing. Sorry. So and you were using Roth for that. That's pretty great.
Right.
So at Amdahl, you are porting Unix, AT&T Unix, Bell Labs Unix,
right,
to their mainframes.
Yeah. So I arrived at Amdahl. Well, I interviewed first in January '78, and it's the week after I interviewed with IBM, where I got snowed in for an extra day. So out here, it's gorgeous, wonderful weather. So I was like, yeah, I think I'll come out here.
Some people like to overthink like the Silicon Valley, the allure of Silicon Valley.
Right.
It's the weather, stupid. It has drawn technologists here for time immemorial. Is like the weather is pretty good.
Right. So then Amdahl had me back for spring break to start consulting, start the project going.
Wow.
And I physically brought my Unix on deck tapes with me. Amdahl made an agreement with Princeton to get the project. And I still have those deck tapes, which were recently recovered.
Oh, wow.
By the folks at the Living Computer Museum in Seattle.
Oh, that is awesome. And have you been to the Living Computer Museum?
No, I haven't been to the one in Seattle, but I want to.
Yeah,
it is mind-blowing. They have, 20 or 30 working computers from the 70s era.
That sounds dope.
That is amazing. And so they've got it working there, or they're able to extract the stuff off the tapes.
And they sent me a tiny little email containing everything.
Whoa.
right. It's an attachment now to an email, right? That is great. And so you've got all your own. It must be really mesmerizing to look at your own work from so long ago.
Yeah. You can't really remember who did what, why, or anything, but
right.
But but anyway, Amdahl. This was still version 6 Unix because version 7 had not made it out of Bell Labs yet. And so we got that working. We wrote editors that worked. One of my things I'm proudest of was doing a device driver for this IBM 3270 terminal. And in the IBM world, everything is record oriented, right? And the terminals must not disturb the mainframe unless absolutely necessary. It was all local form entry kind of stuff.
Interesting. So the terminals have a lot of, they've got computational power on the terminal, effectively.
Yeah, but mostly it got in the way of things. But,
right.
But anyway, trying to get that to work with the Unix notion that everything's full duplex, and it was a challenge.
Interesting.
But anyway, we had a whole V6 system up with probably 100 internal users at Amdahl before V7 Unix ever came out.
Wow.
And V7 was the portable Unix where it was easier to do that.
And did Amdahl view Unix as a big part of their future? I mean, they're competing directly with IBM and making an IBM compatible mainframe effectively.
Yeah. So it started out just as a time series system for the electronic design automation people to do stuff.
Okay. Right.
To further building hardware. Then it leaked into the operating system for the console processor. So the original Amdahl mainframe had a Data General Nova as a console processor, 16-bit machine, and people were grumbling about that. So the next generation, they were actually going to be 11 running Unix, but they were going to implement their own PDP-11 because you don't buy computers from another computer company.
Right.
But they stumbled across a couple of patents, the famous Unibus patent and stuff like that. So they said, no, we're not going to do PDP-11. So they ended up doing a 370 subset on a tiny little console processor. And so they ran Unix on that.
Huh.
And so it was buried inside all the Amdahl mainframes.
Got it. Okay. But it was a smaller implementation detail.
Yeah. And then later on, they came out with the actual UTS, they called it.
Unix time track system, right?
Unix. I don't know if it ever officially stood for anything. And then that was fairly popular, especially in the Bell system and universities.
Right. And so you were at Amdahl so then what lured you away when did you first hear about this crazy company that was starting?
So it turns out because of my mafia of brothers, right?
True mafia. I mean, that is, it's really scary.
So my brother Dick was working at Xerox PARC at the time.
Oh, wow.
Oh, nice.
My brother Bob was working in the Xerox Star group. And they had friends from Stanford. And the Sun stuff was, of course, happening at Stanford, all the Sun hardware development. And so the Valley was already kind of a buzz. It was like, oh, cool processor board out of Stanford. And what could be done with this? And so at Amdahl, Berkeley had become the center of the West Coast Unix universe because of Bill Joy. So I had been up to Berkeley a few times and met him and chatted. But one day I get a call from this guy, Scott McNeely. And he's like, hey, Tom, we're doing a little startup. Have you ever heard of this thing called the Sun board? I'm like, oh, yeah, 68,000. So Scott is like, ding, 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 ding.
Right.
Somebody's heard of this, right? And I was on Bill Joy's list of Unix people to call up.
To call up.
So that's why Scott got my name.
That's great.
And I was looking for a startup, basically, because it was still startup fever all the way back then as well.
Right.
Yeah. It's just what you did in Silicon Valley.
Right. Yeah. I mean, it's amazing how permanent that kind of cultural idea is, right? That around new company formation.
So yeah, it worked out well. I was clueless about so many things back then, but it worked out.
No, that's great. And just to be at the epicenter of it all. I mean, because you surely could not have guessed that Sun was going to be playing such a central role in the next 15 years, effectively. I mean, I don't know. Maybe it was clear from the beginning.
Yeah. Well, it was.
I guess you had Bill Joy. You knew that you got actually between Bill Joy and Andy Bechtolsheim, this is like.
Right. And my exposure to the Xerox Alto stuff. Right. So that was the coolest thing ever in terms of personal computing. And then I was a dyed-in-the-wool Unix guy by this time, so bringing those two together
seemed natural.
Was perfect.
So when did you see the Xerox Alto? Was this through your brother that you'd seen it?
Okay. I'd been up to visit him.
You'd been up to visit him and you'd seen, and that must have felt like seeing the future. Yeah.
I mean, I don't remember it that well, but clearly it was a hot thing, hot place to be.
Yeah, I'm reading Dealers of Lightning now, which is a really interesting book about the development of Xerox PARC. But the laser printer, you forget that the laser printer was actually.
Oh God, they had generation after generation of these color printers where the pages would come out on fire and all this stuff.
That's cool.
That's great. So you could see, if you could take the Alto, but what was the Alto running for an operating system?
A bunch of homegrown stuff.
Right. Okay.
And Xerox PARC actually did a PDP-10 clone.
They did a PDP-10 clone, which I did not know until reading this book. It's Max C.
Max C, and they ran a whole lot of their own software, but some other software, and they had file sharing and all that stuff.
Yeah, this is something that Chuck Thacker put together in whatever. It was 6 months. They built their own machine from scratch. It was crazy.
That's crazy.
Actually, that whole core group came out of Berkeley Computer Corporation.
Yeah, Berkeley Computer Corporation. Right. Yeah. Which I had not learned about until this book. But
I still don't know enough about them, but it was quite the seminal group.
It feels like they burned through a lot of money. They were like an early. I would love to read a book on the Berkeley Computer Corporation because they clearly had a lot of good ideas, interesting people, but also no real financial discipline.
Right.
But another story that's as old as Silicon Valley for sure. So you saw that this could be a big deal to combine these folks and these ideas. This is going to go places.
Yeah, and I wasn't taking it too seriously because I felt like I was employable. So what the heck, try something out.
I feel that that's actually an important point. I think that the kind of the security of a fluid labor market allows you to take much greater risks
Totally.
in your career.
Now, it turns out I had just bought a house with my brother Bob and his wife, so we were divvying it up 3 ways. And this was a point in time when interest rates were about 15%.
Oh boy, right.
So the monthly mortgage was quite astounding.
Okay.
And so he's like, "You're doing what?
Okay, so he thought you were crazy.
You're going to a startup? What if? And I'm like, don't worry. And then a year later, he's joined me, right? Because everything's going so well.
So
Nice.
he joined you pretty shortly thereafter.
Yeah.
It was pretty clear that it was, because I mean, Sun did.
Well, Sun is just such a rocket. I mean,
Right.
So I joined in May of '82. The first revenue shipments were actually 3 megabit Ethernet cards.
Huh.
And he did a whole stack of these for somebody. That was our first revenue in the same month, May. And then first week of June, we shipped our first workstation.
Wow.
Nice. That's fast.
Yeah.
Yikes.
And it was a rocket from there. And because everyone knew Bill Joy was joining, the entire Unix world
was a buzz.
Was a buzz.
Right.
And then John Gage,
Right.
he came on board as our sales guy. He was a terrible salesperson, but he knew every scientist, computer scientist, rock star, news person on the planet. And it's just everybody knew all of a sudden. So it was great.
That's great.
That's cool.
Wow. Yeah, that would be great. And actually, behind you in the garage here, we have I don't even know where this piece of artwork came from that was in Mountain View 5, somehow made its way to Menlo Park 17, which is where I found it in a trash pile with the optical mouse. And we'll put a photo of this thing in the show notes. But because that is a machine that would overlap with you, right? That is
Yeah. That's, I don't know what it is, but I have a story about a mouse though. So
Yeah, that mouse is crazy.
go on. What's your story about a mouse?
So my summer at Bell Labs, they put us up for housing at Fairleigh Dickinson University. So I shared a suite with 5 other guys also working for Bell Labs. One of them was Steve Kirsch from MIT, who importantly taught me how to juggle that summer, because that's a computer science thing. You got to know how to juggle.
Right.
He went on to form Mouse Systems Corporation. He invented this mouse that's in the
optical
picture.
mouse.
Yeah.
Wow.
So he invented the optical mouse, as well as my brother Dick also did it at Xerox.
Whoa.
Wow.
That's cool.
Completely independently.
Completely independently.
Right.
And so, we've been, because obviously with an optical mouse on the wall, the optical mouse is a subject of conversation around here.
Yeah, definitely come up.
These predate the rollerball, effectively. Or was this more precise than the rollerball? Why the optical mouse?
It's more reliable because
Okay.
you always get gunk in the roller balls.
Oh God, yeah, that's so gross. I remember cleaning out the dust. Oh, I just remember that. Sorry, that was very vivid.
Yeah, so it was a much better experience with an optical.
And more precise for EDA and so on.
Yeah.
For the interesting. Wow. So you independently invented it.
Right.
That's always.
And my brother did a Xerox technical report on the optical mouse, and it was the first Xerox technical report printed with color inserts from their brand new color laser printers.
Right. Wow.
So that dates it.
That dates it. That dates it to. So when is that? That's
Like 1980.
Yeah, I was saying like very early 80s, right? Yeah, because I mean, the laser printer itself, I'm reading about the trials and tribulations, just getting that thing working. That's that's amazing. And the optical mouse has since obviously fallen away, I think, because these mice, and I don't know if your brother's was the same way. Did they require the mouse pad to have a particular orientation? If you flipped it 90 degrees, it no longer worked.
Yeah, well, my brother's was orientation independent, which is cool. But the pad was a grid of dots in a hexagonal pattern.
Okay.
And I never quite figured out how that worked, but it worked no matter how you turned it.
So it sounds like that's the better technology.
Yeah.
Yeah.
Because the Sun technology I always felt was a little bit brittle because the orientation of your mouse pad would screw you up. So fast forward, beyond Sun, you went to Ypsilon, and I arrived in 96. I feel like you left maybe in 95 or 94 or something like that.
Yeah, 94.
94, right? Yeah.
Yeah, so I got caught up in ATM networking,
Right.
which which the short description of ATM is it's the kind of ATM you only put money into.
ATM humor, a little ATM joke. Do you know ATM is a technology that you would not necessarily?
I thought you meant like an ATM machine.
No, but that's the joke.
Okay.
No, ATM is asynchronous transfer mode. This was a frequently hated upon protocol, I dare say. I mean, the kind of the knock on this was this is the way for the telcos to actually meter the internet. That was always.
Yeah,
I'm not sure that's fair or not.
It definitely came out of the telco world, and it was very odd because it had 48-byte packets with 5-byte headers, and it was guaranteed not to fit with anything else. But it's for the synchronous phone world, envisioning a world where everything worked with no buffering at all anywhere, right? So it's just not the world we have today. But
right.
And what was cool about ATM is you could easily visualize how to build a switch. Right. And switches came from the telephone world of voice switches.
Well, I mean, it's appealing. You've got these all packets of the same size.
Right.
They are all this constant small size. You can, I mean, lots of things are.
Yeah. So that's what sucked me in. Is like, you could build a switch with these.
Right.
Little did I realize that there are people starting to build Ethernet switches at the same time.
Right.
But it just wasn't as obvious how you would do that.
Yeah, I remember I think when I first moved out to Silicon Valley, I subscribed to the Red Herring magazine, as one did back in the day. And I think one of the first red herrings I have is Andy Bechtolsheim with the Death to ATM cover.
Whoa.
With him, because he was at a company called Granite that was doing Ethernet switching, right?
Right.
So, but Epsilon was doing ATM switching effectively.
Yeah. And so we set off with the observation that the ATM standards, they were building brand new random stuff that the telcos liked that had no bearing whatsoever on what you would like a TCP/IP network to look like. And so I came along and said, look, get rid of all that higher level protocol stuff. We're just going to operate the ATM switches with IP routing.
Oh, interesting. And hence the IP in Epsilon.
Right. And so we call it IP switching because you were able to switch IP packets at ridiculous speeds.
Right.
And it was all pretty clever. What was really fun was kicking Cisco in the shins because at the time, Cisco sold lots and lots of routers, but they were all based on relatively slow MIPS chips, and the forwarding was all done in software. Right. So even a Sun workstation could do a better job than a Cisco router. Right. And an ATM switch was like orders of magnitude faster.
Right. Because you're able to presumably do a lot of this without actually having to even, I mean, were you doing it in silicon or were you able to do a lot of this?
Yeah, the ATM switches were all silicon, silicon data path. Right. So we had to surround the ATM fabric with software that would put things on the right channel, basically.
Right.
So it was some software, some hardware, blah, blah, blah. But anyway, we did a lot of partnering with ATM switch companies. And in some ways, we invented the core of some of the software-defined networking stuff you see today.
Oh, interesting. Huh.
Because we were managing a switch from the outside. So the control and the switching were separated. And so it was a fun time.
Yeah, that sounds fun. And Epsilon was ultimately bought by Nokia, if I remember correctly. No?
That's right.
Okay.
And it wasn't that long into Epsilon when people figured out that Ethernet switching was going to be the way to go.
Right.
And there were all kinds of startups. And we actually had a team of hardware people come to us and say, hey, you should hire us and we'll do a Ethernet-based thing for you. And we said, nah. And they went off to be very successful. So we missed the boat in a couple of ways.
Right.
And same thing, one of our key guys left and became a founder at Juniper Networks.
Oh, there you go. Yeah.
And so they did IP routing directly in hardware.
Right.
So it was all going downhill when we were talking to Nokia. And Nokia, coming from the telco world, we thought they wanted all this ATM stuff, which we were at the point of saying, oh, this is never going to fly.
Interesting.
So there's this weird tap dance, and it finally came out that no, what Nokia wanted was some IP routing expertise. So I was like, oh, hallelujah, this is perfect. So
well, that's always funny, right? When you're trying to impress them with all of your ATM savvy, and they're like, actually, we're actually much more interested in the IP.
Yes, yeah.
That's interesting. And then how long were you at Nokia? Or were you at Nokia?
Yeah, solid 3 years or so.
Yeah, interesting.
Many trips to Helsinki, which was a fun time.
Right.
And this was when Nokia was king of the world, right? So year 2000, they were the most valuable company in Europe.
Oh.
Yeah.
Right.
Did you? You must have had a Nokia. Did you have a Nokia phone?
I did.
Yeah.
I had the one that everyone had that you could play Snake on.
Exactly. Yeah. This is going to date you in not long. It already does date you, actually.
That's the one everyone had.
I know, but I'm just saying, like, the Gen Zers coming up are going to view you as like wow, you are really old.
Well, you can buy brand new phones that are clones of those, and Snake is still one of the key features.
Whoa, nice. I don't even remember the model number. Like, I feel like shame right now. Like, I can't.
Yeah, well,
It's very popular.
There were a lot of models.
Yeah. I just remember the Nokia, I think, was the first phone I had that had a built-in camera in it, which was great. But of course, I was much older. Interesting. And then after Nokia was the drive scale, after Nokia, or where did you end up?
So after Nokia, kind of had my first retirement where I fiddled around and consulted with some VCs and had a nice office in downtown Palo Alto.
There you go.
Nice.
And the major thing I accomplished then was getting into Linux because I had been FreeBSD guy at Ipsilon. So that was like 2001. Then eventually I got itchy, so I started another startup. It was called Netillion, and I pulled some people out of Sun, et cetera. So Satya Nishtala, who's my co-founder now at DriveScale,
Right.
That's when I pulled him out of Sun.
Got it.
And we were going to do a distributed shared memory product for basically connecting CPUs to be SMPs over Ethernet.
Okay.
And it was way too early for that.
Yeah, that's that. It was early. Yeah.
And we discovered two other companies were already doing it.
Right. Right.
Which one of whom survives today, amazingly. Scale MP.
Huh.
Doing just that.
Wow.
So we piddled around for a year, and the VCs didn't really see anything interesting. So they said, I think you're done.
Right.
So I went around trying to sell the group of engineers to whoever was interested, and talked to Cisco. At that time, the core team from Cisco, which is MPLS, Mario, Prem, Luca, Sony.
Right.
They were leaving Cisco to start a new startup / spin-in. And they had done this spin-in previously for fiber channel stuff. But
this is Nuova, right? This has got to be Nuova.
Nuova, yeah. That's what they were forming.
Right.
So
right.
They saw I was loose. They called me up, and it was good because I brought a whole engineering team with me.
Yeah.
As a co-founder at Nuova.
All right, we will be taking another break. We'll be right back with Tom Lyon and more On the Metal. On the Metal is brought to you by the Oxide Computer Company, where we're going to try a new feature shamelessly ripped off of Reply All's Yes, Yes, No, where our boss, Steve Tuck, brings us a tweet he does not understand, and Jess and I try to explain it to him. Steve, do you have a tweet?
I sure do.
Go for it.
The tweet in question: UEFI pre-boot network stack engaged the onboard NIC in such a way that it would write back DMA to particular physical memory pages sometime after control was passed to the bootloader. Corruption would occur somewhere in the user parts of the RAM disk. No idea.
No idea. Jess, do you understand this tweet?
So I understand definitely the part about the UEFI pre-boot networking stack, but the part about DMA is in question marks. So it's like, I guess you're not really sure where that's
You're
going.
overthinking it. I understand this tweet. Running on-prem is painful. This is dealing with an awful firmware bug. The firmware has overwritten part of the operating system in a way that is extremely painful to debug.
So who do you go to in that case?
Who do you go to?
You definitely strangle one of your vendors.
You strangle one of your vendors, and unfortunately, your vendor is a PC vendor because all of the existing computer companies are selling personal computers. What we need is a new computer company.
So this is just saying I'm in intense pain trying to run systems on premises.
That's exactly what it's saying. Steve, what can someone do if they're in intense pain running on premises?
Well, if someone is running in intense pain on premises, what they should do is go over to oxide.computer to learn a little bit more about how we are going to take that pain away.
Help is on the way. Join us at oxide.computer.
You are not alone.
All right, we're back with Tom. So Tom, as you know, Jess and I, along with Steve Tuck, have started a computer company, Oxide Computer Company, and as a result, we have gone back through history about, when are the kind of the recent attempts at doing this, and Nuova is obviously one of the big ones, one of the important ones. It's a computer company that was started in the early 2000s, effectively.
Yeah, 2005,
right.
I guess.
And by the MPLS cruise, MPLS is a protocol, but it's also the names of the
initials of Mario, Prem, Luca, and Sony, who's this gang that have been together ever since that Crescendo Communications that did the physical layer stuff. And then Mario ran all of engineering at Cisco. Luca was his right-hand man. And Prem has been everywhere. He's really good. So it was a gang to contend with.
Right.
So it was a no-brainer for me to join them.
Yeah.
And then that became Nuova Systems.
And Nuova is really going to take a from scratch approach or try to take a clean sheet of paper on, on the compute side.
Basically they were saying, look, there's this wall between servers and networking that doesn't really have to be there. And so how can we rethink who does what and in some more efficient way? And so we did a lot of interesting stuff. But business-wise, it became structured as a spin-in because Mario had the power to hire absolutely anyone he wanted from Cisco. So to stop that happening, Cisco had to come up with a framework where
that is great. That's like it's like a preventative acquisition. Like the only way to like actually prevent you from just hiring away our best and brightest to actually acquire you.
Right. And so so he did the second best thing, which was to hire away all the people who had already left Cisco that he knew were good.
Right.
And in particular, we got J.R. Rivers and Dan Lenosky. I think they both came out of Google. And they're both amazing people. They did so the first product we did was 10 gig Ethernet switch in a way that was really the first economical 10 gig Ethernet switch.
Oh, interesting. I didn't realize that you guys did your own switch. Okay.
And Cisco knew how to sell switches, so that was a no-brainer. It pissed off a lot of people in Cisco who were also building 10 gig switches.
And so was the structure that this had been, it was a spin-in, right? So it was acquired very shortly after.
Yeah, but basically after we hit the development milestones, then we were acquired.
Okay, got it. But you're an independent group effectively within Cisco.
Right. But then doing the switch, that we viewed that as like the easy part, and we wanted to do something more significant with servers and whatever. That was a much more difficult discussion with Cisco because they didn't know how to sell servers.
Right. You said switches? No, I said servers. Like I heard switches.
Right. So that took quite a while to iron that out.
Yeah.
But then we did the UCS system, which had a number of really interesting things about it, including one of the first smart NICs where, what happened on the PCI bus was really controlled by the network, not by the server.
Interesting. And so was that the VIC? Was it the VIC that
the VIC
is that effectively that early smart
NIC? We never called that internally, but that's the external name.
Yeah, exactly. That's how I know. What'd you call it internally?
The Palo.
Palo.
After Palo Alto.
The Palo Alto.
Nice.
All right. Now I can be like, Jesse, you and I can be cool with the VIC crowd. We can be called the Palo.
We also had a Menlo chip, but that was not cool. That was just a fiber channel translator. So.
Okay. All right. So Palo was much cooler than Menlo. That's good.
Good to know. I'll avoid.
Yeah. And so, but you guys were also doing some interesting things on firmware, right? Because I know that there was some interesting BMC work going on. I mean,
we had a very tight relationship with Intel because they were happy to see another contender in the server world.
Right.
So we did a lot of firmware work with them, trying to, again, all pointed at making things more manageable, which of course remains a huge problem with the BMCs today.
Huge problem, right.
Cisco UCS had the server profile thing where you could really control the whole identity of the server, MAC addresses and UUIDs and all that kind of stuff.
Right.
So you could move that identity around between different physical pieces of hardware.
Yeah, what were some of the big lessons of that in terms of like what worked? Because I feel like this is like one of really the last attempts at taking things from scratch that are not in the hyperscalers. It was in this, and that became UCS.
Right.
What were some of the things that really worked from that?
Well, a lot of it never quite mattered
right.
because everything ended up in virtual machines.
Right.
It became a very, very VMware-centric product. And then VMware was taking over a lot of the management stuff. So then it became this uneasy tension between Cisco and VMware about who's doing what and why. And I was fortunately not deeply involved in all that.
Right.
But I didn't, I as soon as Cisco took us over, I kind of checked out in many ways because the Cisco culture is so alien to me.
And so I think that like if open firmware had been around, I mean, a lot of the challenges from Nova, it sounds like, we're dealing with all the proprietary firmware that you had to go partner with effectively. And
well, there's that, and we did a unnecessarily complex system in my view.
Interesting.
where we had, not only the firmware on the server boards, but we had a local switch in the server box. Only it wasn't a switch, it was a fabric extender, which is a new concept.
Right.
And then the switch was top of rack, and we're doing software up and down the stack. We're doing chips for all these things.
Right. Okay. Wow.
There was a lot of stuff going on.
And that was all internal to Cisco. So the budget is actually much larger at this point.
And even at Nuova, it was, I don't know, we were doing like 6 chips at once.
Wow.
It was pretty silly, but we had the people who could crank these things out.
That's amazing. So you left Nuova at some point.
Yeah, I invested in peace.
Invested in peace, as they say, right? And then it was DriveScale time. It was DriveScale was the
well. The thing I did at Cisco, which was kind of a research project for me, was I got interested in low latency networking, and why does InfiniBand claim to be so much faster than Ethernet?
Yeah.
Blah, blah, blah. And basically did a user level framework for Ethernet drivers, which turned into the VFIO subsystem in the Linux kernel.
Yeah, right.
And so I'm kind of proud of that, of creating a framework where you can actually do user level drivers safely.
And you can actually rival IB.
Right.
Performance.
It turns out all the performance IB comes from OS bypass.
Right.
It has nothing to do with the protocol.
Right. In fact, it's despite the protocol.
Right. Yeah. So protocols are protocols. Yeah.
Right.
So that was cool.
Yeah. Neat.
That was kind of my side project.
Right. There you go. The 3 of us last saw one another at the Open Source Firmware Conference, which
It was awesome.
Yeah, I love that.
That was a great conference.
Wasn't it great?
Yeah.
It's really
That's
good.
the kind that should be a small enough community that they're all fun and interesting.
And I know I've said this before, but I was telling Jess, I'm like, this is what conferences used to be like. I felt. Did you feel like that was like
like the early Unix days and stuff like that.
Yeah.
Before like everything became a trade show.
It just felt like this group of, it's like working on kind of esoteric technology, really.
Right. I mean, most people still, it's like open source firmware is like, who cares?
Right.
Right. But those of us in the know, it's like, this is really important.
This is really important. Yeah. So why is it important from your perspective? And we certainly have our perspective.
Really nothing to do with my business.
Yeah, right.
Thing. It's just, there's just been so many attacks at so many levels on these compute elements that, it's time to protect ourselves.
Totally.
Yeah, it is. And time to get, I feel like, really much more modern software, much deeper in the stack. I mean, it's terrifying how much we've of this.
Well, the other thing besides NFS I wish would go away is C.
Yeah.
Right? It's just time to stop. We've had enough.
Yes. So what is post C? And we obviously have our opinion on this.
It's Rust.
All right. There we go. Yeah, exactly.
if you're doing that level of systems programming.
Yeah, right? Yeah, yeah.
And then Go has its place.
Go has its place. Yeah, yeah. I kind of
Python is awesome. But.
Yeah. It also has, I feel like all this stuff has its place, but it does feel like Rust is replacing C.
Yeah.
And it feels like this is a not uncommonly held view from people who came up when C itself was revolutionary. I think it's interesting to me how many folks who remember when C replaced assembly are now seeing a lot of the same things, same reasons that C replaced assembly, they are now seeing in Rust replacing C. I mean, is that a fair characterization?
Yeah. And it just saddens me to see major new things still being written in C++ or C,
it's like, why?
Gag me.
Yeah. Well, especially when, I mean, it just does feel like, and I mean, because Tom, you like us, I mean, we are not really, I'm not a PL person at all, right? I just view I just view a programming language as it's an important way of expressing a system, but it's kind of, I've always viewed it as a necessary evil, I guess. With Rust, it's been very exciting to feel like, wow, this is an actual like technological step forward in the programming language that is helping me as someone who's actually deploying a real system.
Yeah, I actually have not started programming in Rust, but
there you go.
I really want to. I want to find some excuse to.
You got to find some excuse. So here's what I think you will find, or what I found, is you remember when you're programming C, you could feel the underlying assembly.
Yeah.
With Rust, I think you can feel the underlying C. So I think as a veteran C programmer, Rust will have less of a learning curve for you, because I think that some of the things that it wants to do, I don't know if you're a Java programmer, Python programmer or something, it's going to be very confusing about why the Rust compiler is being upset about various things. But the ownership model makes so much intuitive sense if you're coming from C, I think.
Yeah.
Well, that is, I feel that's a great tour from ROF on the mainframe to 600 lines per minute of printing to Rust. Tom, we cannot thank you enough. This has been,
thank you.
This has been just.
You're throwing me out already.
Yeah, exactly. We can go. I feel like I feel that these could go on for days because I think there's so much interesting stuff out there.
Yeah, we haven't really talked about drive scale, but the short.
Oh yeah, so sorry. I'm so sorry. Let's talk about drive scale. Yeah.
Well, the short thing there is we're trying to make servers simpler. Get stuff out of servers, put them on the network, put it on the network. Tie it all together on demand. It's very simple.
And so yeah, people want to learn more about drive scale. What's the place to? I mean, you've been at the epicenter of so many technological revolutions. I'm sure people are going to be interested to learn a lot more about drive scale. Where should they go do that?
The usual website.
Okay.
So I don't know where else to start, but there's been a fair amount of stuff written up about us.
And you've got your own podcast.
I do, and kind of in hiatus, but there's a bunch of episodes out there.
But people can go catch up on if they want more Tom Lyon. That's
if you want to hear the same stories again, it's probably out there.
I want to know when we're doing the Lyon family reunion.
Yeah.
I mean,
is that for Thanksgiving? Or?
Yeah, I mean, it's like, do you?
So we're all getting together in El Paso for Christmas.
Oh, nice.
Wow.
So all 9 siblings, spouses, kids, grandkids. It's going to be about 30 people.
I feel like the Computer History Museum needs to send a film crew there. I mean,
yes.
Yeah. Don't you think?
Yeah.
I mean, it's just so incredible to have such a family that has done so much, and hopefully everyone gets along well enough.
Yep, that's all good nerdy fun.
That is great. Well, Tom, thank you again, and thank you so much for joining us in the garage today.
Yes, thank you.
It's been terrific, and I know that I'll look forward to more stories from you for sure.
Okay, thank you for having me.
Excellent, thank you, and thanks for joining us for On the Metal: Tales from the Hardware Software Interface. You've been listening to On the Metal: Tales from the Hardware Software Interface. For show notes, to learn more about our guests, or to sign up for our mailing list, visit us at onthemetal.fm. On the Metal is a production of Oxide Computer Company and is recorded in the Oxide Garage in Oakland, California. To learn more about Oxide, visit us at oxide.computer. On the Metal is hosted by me, Bryan Cantrill, along with Jess Frazelle, and we are frequently joined by our boss, Steve Tuck. Our original and awesome theme music is by JJ Wiesler at Pollen Music Group. You can learn more about JJ and Pollen at pollenmusicgroup.com. We are edited and produced by Chris Hill and his crew at HumblePod. From Jess, from Steve, from me, and from all of us at Oxide Computer Company, thanks for listening to On the Metal.